YouTube. Today we will discuss a mathematical derivation and their mathematical concept associated with Schrödinger wave equation. Now suppose a wave associated with a moving material particle moving along plus x direction. Then wave function associated with the moving material particle can be taken as psi of x comma t equal to a e raised to the power minus I h cross e into t minus x into px. Here a represents amplitude of the wave, while h cross is a constant given by h over 2 pi, where h is the Planck's constant. Now again, suppose particle is moving along x-axis in a potential field, then its total energy can be written as, which will be equal to sum of kinetic energy half mv square plus potential energy v, or in terms of momentum, kinetic energy can be written as p square x over 2m plus b. This is equation 2. Now multiplying equation 2 with the wave function psi x comma t, that is e into psi x comma t is equal to p square x over 2m plus psi x comma t plus v psi x comma t. This is equation 3. Now differentiating equation 1 partially with respect to x, we have del psi x comma t over del x is equal to a I over h cross px e raised to the power minus I over h cross e into t minus x into px. Again differentiating partially with respect to x, we have del to psi x comma t over del x2. This will be equal to I over h cross px square multiplied by a e raised to the power minus I over h cross e into t minus x into px. This is equation 4. Now again differentiating equation 1 partially with respect to t, that is del psi x comma t over del t is equal to minus I h cross into a raised the power minus I h cross e into t minus x into px. Applying by I, numerator and denominator, we have del psi x comma t over del t equal to I minus I square into e over I h cross a e raised the power minus I h cross e into t minus x into px. Del psi over del t, this will become psi, hence we have e into psi x comma t over I h cross. Now e into psi x comma t equal to I h cross del psi x comma t over del t. This is equation 5. In a similar way, consider equation 4. Del square psi x comma t over del x2 equal to minus p square x over h cross square a e raised the power minus I h cross e into t minus x into px. On cross multiply, minus h cross square del 2 psi x comma t over del x2 equal to p square x. This will give you wave function psi x comma t. Now putting the values of equation 5 and equation 6 in equation 3, we have I h cross del psi x comma t over del t equal to minus h cross square del 2 psi x comma t over del x2 divided by 2m plus v into psi x comma t. Taking all the term in left hand side, we have I h cross del psi x comma t over del t plus h cross square over 2m del to psi x comma t over del x2 minus v psi x comma t equal to 0. This is a one dimension time dependent Schrödinger wave equation. In a similar way, three-dimension time-dependent Schrödinger wave equation can be written as I h cross del psi x comma y comma z comma t over del t plus h cross square over 2m del square psi x comma y comma z comma t minus v psi x comma y comma z comma t. Okay, students, this is the derivation of time dependent Schrödinger wave equation. Now we will derive time independent Schrödinger wave equation. Time independent Schrödinger wave equation we will discuss in next lecture. Okay, thank you students for watching my video. Please like, share and subscribe. Thank you.